In this video, we're going to go over some fundamental trigonometric identities. And earlier in the year, we talked about what an identity is. An identity is an equation that's true for every value of the input that's in the domain. So these fundamental trigonometric identities are always true, and you are going to be responsible for knowing them. So let's begin. The first one that we have is sine theta is 1 over cosecant theta. These are called reciprocal identities. The reason they're called reciprocals is because one trigonometric function is the reciprocal of another. And we've already learned this. This was how we defined cosecant theta as 1 over sine theta. So sine theta is 1 over cosecant theta. Cosine theta is 1 over secant theta. Tangent theta is 1 over cotangent theta. We can also rewrite these. If sine theta is the reciprocal of cosecant, then cosecant is the reciprocal of sine. Secant is the reciprocal of cosine, so secant theta is 1 over cosine theta, and cotangent theta is the reciprocal of tangent theta. So cotangent theta is 1 over tangent theta. The next identities that we're going to look at are quotient identities. They're called quotient identities because one function is being divided by another function. So tangent theta, it can be thought of as sine theta divided by cosine theta. And then cotangent theta is the reciprocal of tangent theta. So that means that cotangent theta is going to be the reciprocal of this ratio that we just wrote, sine theta over cosine theta. So cotangent theta is going to be cosine theta over sine theta. And the last three identities that we're going to look at right now are called Pythagorean identities. They're called Pythagorean identities because they come from right triangles, and they look like the Pythagorean theorem, right? A squared plus B squared equals C squared. So if we write sine squared theta plus cosine squared theta equals 1, this is the first identity. We can also rewrite this in different forms. Sometimes it may be helpful to use this by subtracting cosine squared theta from both sides. So maybe you might see 1 minus cosine squared theta is equal to sine squared theta, or you might subtract sine squared theta from both sides, isolating cosine squared theta. So you might see this as 1 minus sine squared theta equals cosine squared theta. So it might be helpful to use these identities in various forms. The next identity is 1 plus tangent squared theta is secant squared theta. And the way I remember this, it's kind of silly, but I think it'll help you remember. I say this phrase, I tan in seconds. And then the third identity, Pythagorean identity, is 1 plus cotangent squared theta equals cosecant squared theta. And we can have another silly sentence, which is I cotan in coseconds. So the 1 corresponds with the I, tan with tangent squared theta, and seconds corresponds with secant squared theta. Please note that sine squared theta, this notation right here, sine squared theta, really means sine theta times sine theta, or sine theta, I could put that whole thing in parentheses and then square that. The reason we move the exponent in between the n and sine and the theta is to make sure we know that it's not the sine of theta squared. So it doesn't mean sine of theta squared. So this is not the case. Finally, I'm going to show you how these Pythagorean identities can be derived quickly using a right triangle. So if we start with the Pythagorean theorem, normally we would write a squared plus b squared equals c squared. In the contents of right triangle trig, SOHCAHTOA, instead of a and b for the legs, those are the opposite and the adjacent sides. And the c is the hypotenuse. So we would start here with, this is the Pythagorean theorem. We would have opposite squared plus adjacent squared is hypotenuse squared. That's the same thing as a squared plus b squared equals c squared. Now, what we're going to do is we're going to divide by the hypotenuse squared, that length squared. When we do that, what we get is opposite over hypotenuse, that is sine squared theta. Adjacent squared over hypotenuse squared is cosine squared theta. And hypotenuse squared over hypotenuse squared is simply 1. That's the first Pythagorean identity. We can do the same thing, but now we'll divide by other side lengths. So we start with Pythagorean theorem. So opposite squared plus adjacent squared is hypotenuse squared. Divide both sides of the equation by the square of the length of the adjacent side. You get opposite squared over adjacent squared. That's simply tangent squared. Adjacent squared over adjacent squared is 1. Hypotenuse squared over adjacent squared is secant squared. Right? So in the second one, we divide by the adjacent side squared. And then the last one, for the last derivation, we're going to divide by the opposite side length squared. Right? So we're going to start, once again, with the Pythagorean theorem. Opposite squared plus adjacent squared is hypotenuse squared. Divide both sides of the equation by the length of the opposite side squared. Then we get opposite squared over opposite squared is 1. Adjacent over opposite is cotangent squared. Hypotenuse over opposite is cosecant squared theta. That's where they come from. And I have a little note at the bottom. So if you remember sine squared theta plus cosine squared theta equals 1, you can also derive 1 plus tangent squared theta equals secant squared theta by dividing all terms in this original relationship by cosine squared theta. And you can derive the third one by starting with sine squared theta plus cosine squared theta equals 1 and dividing all the terms by sine squared. And then you'll get 1 plus cotangent squared theta equals cosecant squared theta. You can also remember the little mnemonics, I tan in seconds and I cotan in coseconds.